resistance, right?
Coefficient of resistance.
We have the resistivity and we also have the coefficient of what? Temperature coefficient, right? Alright here.
Okay.
So it's a fractional change of what of the resistance of what of 0 degree of what of the temperature, right? Rise. Of any given temperature. Now what is the fractional change here? Now so whenever this equation was on coefficient of what of temperature here, or temperature coefficient here, it appears like temperature, right?
Yes, sir.
Where we have a temperature of a fixed point, right? Now, but they are similar actually. What you must understand here, for the fractional coefficient here, we have what? We have r theta here minus what? Minus r0 here, all over what? All over r0. That's the formula for the coefficient of the resistance here. Okay?
In electricity.
Yes, sir. Electricity here. Okay, mind you, on a temperature, we look at what? As theta here is now equal to what? R theta minus r0 all over r100 here minus what? R0, right?
Yeah.
Multiply by what? By 100. But yeah, we're not talking about the percentage here. We're talking about what? Fractional change.
Yes, sir.
Yes, sir.
I have a question.
No problem, sir.
So if you see a question, the
Yes, sir.
coefficient of friction,
Yes, sir.
question,
Yes, sir.
how can you tell? How can you tell that?
Yes, sir. We are going to talk about what? Resistance.
Resistance.
Yes, sir. We have the coefficient of resistivity. That means now, if we have this guy here, now say what? R theta minus R0 all over, we have what? We have R0 here divided by what? By theta, which is what? Which is the temperature, right? Are you okay here? Now, this one is what? Is the coefficient of the resistivity, right? So if that's the case now, what do we do here? We multiply throughout by what? By theta. Okay? So therefore, say this is theta here, alpha multiplied by theta equal to everything here. That is r theta minus r0 upon r0 again here. All over here we have what? We have theta, right?
Yeah.
And we multiply again. We see we have to multiply by what? By theta. Is that also, sir? So if that's the case now, what happens now is this theta and this theta we cancel, right?
Yeah.
And now we are left with what? Alpha theta equal to r theta minus r0 all over. We have what? We have r what? R0.
Yeah.
Are you okay here? Now I can say again we can multiply throughout by what? By r0 to get the first of the fraction.
Yeah.
Or you can what? You can cross multiply. Either way, you do the same thing. Okay? Let's cross multiply here. So here is upon 1, right? Are we okay here?
Yeah.
So 1 times any number is a number itself, right?
Yeah.
And now we are multiplying 1 by what? R theta minus R0, right?
Yeah.
Equal to, and here again, what do we have here now? We have theta, alpha here, and theta here, we have what? R0. Are we okay here?
Yeah.
So, what happens now here? Let's make R theta the subject. So we now say R theta here is now equal to, over here we have what? We have R theta again, right? This one becomes a positive now. Are we okay here?
Yeah.
This one was negative here. Jump in the equal sign, it becomes what now? Positive. Are we okay here?
Yeah.
And over here, what do we have? We have, what do we have here now?
Alpha theta.
We have alpha theta. Let me just put this up for you to get confused. We have alpha theta here, R what? R0 here, plus R what? R0. Are we okay now?
Yeah.
Alright, this one now.
Yeah.
Simple and straightforward, right? Good. It's just the same thing here because commutativity, right? Irrespective of the arrangement, as long as we are multiplying or we are adding.
Yeah.
Alright?
Yeah.
So we go. R theta is equal to, now if you observe something is common here, right?
Yeah.
What is that? R0 is common, right?
Yeah.
If we take R0 outside, so what are we left with now? We now have what? We now have, here is what?
Alpha
It's
theta.
only alpha what? Alpha theta here plus 1. Are we okay here?
Yeah.
Hope this one is clear.
Yeah.
Yeah. Now, R0 here times theta alpha, what is that now?
It's
Same
alpha
as
theta.
this guy, right?
Yeah.
Plus, next one we have here 1, right? Now, R0 multiplied by 1 gives you what? R0.
Yeah.
Hope it's clear, right?
Yeah.
So, therefore, this formula is what we are going to use to solve problems on what? On full equations of force and resistance.
Resistance.
They're all part of the book, right? It's in there. All the proofs are in there. Are you right? Look at them. So therefore, are you okay here? Are you right? Okay, you want to write this one, right?
Yes, sir.
Okay.
Yeah.
I don't forget something.
Are you right here?
Yes, sir.
Yes, sir, let's go.
Yeah.
We go.
A coil of wire has a resistance of 30 ohms
Mhm.
at 20 degrees Celsius.
Now, look at this one here. At 20 degrees Celsius here, that resistor has what? How many ohms?
30 ohms.
30 ohms, right? So what you can see now here, look at this one. This is how we represent these guys. You know, see what? R what? R20, that means what? At 20 degrees Celsius, right? This man has what? It's equal to what? What is the ohms that we have here? 30 ohms, right?
Yes, sir.
Yes, sir. Go again, sir.
And 34.5 degrees Celsius
Mm-hmm.
at 60.
At what?
At 34.5 ohms
Yes.
at 60 Celsius.
Now, 60 degrees Celsius, right? Now, 60 degrees Celsius, we have what? 30 what? 34 point what?
30.5.
34.5 ohms. Yes, sir.
Calculate its temperature coefficient of
No.
resistance.
Temperature coefficient of resistance is equal to what? Alpha. Using here, let me just go here. Now we are asking to calculate what the temperature coefficient, right? Now temperature coefficient here, that is what alpha is now equal to our question, right? But we have our formula, is that not so?
Okay, so the temperature coefficient.
Always it's
is
alpha.
alpha, okay.
Alright, I just tell them now, and they are also part of the book. Now, so using here, now we have what R theta must be equal to we have what I have what R0, right? Into we have what 1 here plus alpha theta. Are we okay here?
Yeah.
This is temperature. Temperature rise, okay? Temperature at what 0 degrees Celsius. Are we okay here? But whenever you have two temperatures here, note that you're going to form what? Two equations. Alright? I will be forming what? Equation 1 and what? And equation 2. Right? And I will solve what? Simultaneous equation. But for this area, the easiest way you can handle that particular simultaneous equation is by dividing what the two equations. But make sure always you divide what? The bigger equation by what? The smaller equation, right? Alright? That means the bigger equation should be at the top and the smaller equation should be what? At the bottom. Hope this one is clear, right? Example here. If we were to derive this one out, look at this guy here. What do you have here? R20, right? But theta here is what? This is for the temperature, right? Theta is for what? Is for the temperature in this formula. This guy is what? For the temperature coefficient. Are we okay here? R0 here is what? When the temperature is what? It's at 0 degrees Celsius. Are we okay?
Yes, sir.
And here we are given what the temperature is. That also, sir. Temperature, when the temperature was at 20 degrees Celsius, what do we have? So therefore, instead of writing it, say resistance at what? 20 degrees Celsius. Are we okay here? Are we okay? So therefore, we can say what? R20 now is equal to, so therefore, anywhere you see theta, what are you to write now? You write 20. Because the temperature by then was what? Was 20 degrees Celsius, right?
Yeah.
So that means anywhere you see theta, and theta there is what is representing what? Our temperature. Are we okay? Yes, are you getting the concept now? No, you are lost, right? Now, from the formula here, alpha is what? Is the temperature coefficient of the resistance. Alright? Not only that, this one is what? Is the temperature at what? At 0 degrees Celsius. Are we okay? Alpha is equal to what? Temperature coefficient. Okay? Are we alright here?
Yes, sir.
Good. Next, what do we have here? You have theta, right? Now, theta, you can see what? R theta here is equal to what? The temperature of the resistance, right?
Yeah.
Or we can say what? Theta is what? Is the temperature, guys. Theta is always for temperature in this case. Anyway, see theta, that temperature given to you in the question is what you're going to substitute. Into what? Into the equation. Are we alright? Now, so therefore, this one is what? Temperature at what? The resistance, right? Temperature at what? The resistance, right? So, next what do we have? We have R0, right? That is the temperature at what? At 0 degrees Celsius. The fractional change of what? Of our resistance at what? At 0 degrees Celsius, right? Of what? Of any temperature. That is what? Temperature what? Coefficient. That's for the definition, right? Just from a past paper here, you can tell that they asked you to define that one, right? Are you okay now, sir? So in this case now, if you observe here, here we have theta. But the temperature at 20 degrees Celsius has what? Resistance for this one here has 30 ohms, right? Are we okay here?
Yes, sir.
Now, temperature at 0 degrees Celsius. So why am I putting what 20 here? Because our formula states that R theta is equal to R0. Temperature at what? At 0 degrees Celsius. Are we right? When the temperature is what is at 0 degrees Celsius here, just put this value there.
So which means
Yes,
the
sir.
first temperature equation is what we should compare.
This one here.
For our theta.
R theta. How many temperatures are given to us in the
How many
question?
temperature?
Two temperatures, right? That was what I was trying to explain. Whenever you are given a temperature, make sure you substitute all of that particular values in what into this particular equation. We have a temperature, right? Now, when you make mention of the first temperature, let's go to the first temperature. Go to the question now. Read the question. Let's see the first temperature and the value for that particular temperature. Let's see. Let's also explain that one, right? Yes, sir. Go, sir.
You say a coil of wire has a resistance of 30 ohms.
Now, we have the resistance, right?
Yeah.
Resistance area is equal to what? 30 ohms, right? Yes, sir. Let's go.
At 20 degrees Celsius.
Now, at 20 degrees Celsius, the resistance was what? 30 ohms, right?
Yes, sir.
So we have theta. Theta is equal to what? 30 ohms, right? Sorry.
20.
Theta is equal to what? 20
20
degrees
degrees
Celsius. Are we okay here? Now let's deal with this guy first for better understanding. The resistance is equal to what?
30 ohms.
At what temperature?
20.
20 degrees Celsius, right? Come to this formula now. We have what? We have R theta, right? R theta is equal to R0 into 1 plus what? Alpha theta. Are we okay here? But this alpha that you are seeing here is what? Representing what? The temperature coefficient.
Yeah.
Are you okay, sir?
Yeah.
This theta that you are seeing here, anywhere you see theta in this particular equation here, that theta is what is representing what? Our temperature. Are you right now? So let's substitute the values now. You have R, which is this man. Now, what was the temperature? Because we have theta here, right? So anywhere we see theta, what do we do now? We represent
20.
theta by what? By our values given to us
20,
for
yeah.
the temperature. Are we okay now, sir? Equal to, are we okay here? So what? R0. Are we giving any value for R0 here? Did they make any mention of what? Of 0 degrees Celsius here? No. What you can do here? There is no value for R0. You write R0. Are we okay now? Into here, now we have what? 1 is a constant, right? Plus, next what we have here? We have temperature coefficient. But the temperature coefficient is not also given to us. From the question, are we giving the temperature coefficient here?
No.
In fact, that was our question, right? That's we have to find what the temperature coefficient.
Coefficient, yeah.
But the temperature coefficient is not given to us. So what do we do now? Write temperature coefficient again. Next step again. We have what? We have theta, right? I want to see theta from the question.
30.
No,
20.
20, right? So multiply by what? By 20 again. That is all. Are we okay here? Now come and simplify. You have 20 here is now equal. I what? I0. Don't multiply with this guy here. Don't do that.
Why?
Yes, sir. Because this I0 is not given to us. So if you multiply, you're going to create more burden for yourself, not for me.
Okay.
So because we are going to have what? You are going to have what? Two equations, right? From the question here, you have what? You have 60 again, right? Then you can see why I did not multiply 2 out, because I will get rid of that man easily. Are you getting the concept now? So I0 here. Here we have what? We have 1 as a constant plus this guy. Do you know this guy?
20 alpha.
No, we have now 20 alpha, right? You have what? You have 20 alpha. But alpha is what? Is temperature coefficient, right? You now have what? You have equation 1. Yes, I want to explain now, right? Let's go to another and let's continue the
So
formula.
anytime they give us 2 temperature, we must end up with like 2 equations.
Yes, of course, always.
So
Two equations, right?
Alright.
Okay? Are you right, sir?
Yeah.
I should have just gone straight to the point. But I want you guys to grab this concept. This is your first time of doing this particular topic on the electricity. Some of us you have bragged that you have done electricity, right? But this is your very first time you have to do particular what? Subtopic on the electricity. So we need to take things step by step for everyone to grab the concept. Yes, are you okay now, sir? Let's go. I can feel your pains. Honestly. Here you go.
And
Yes, sir.
34.5 ohms at 60 degrees.
Now, at what temperature? Look at them. 34 what? The ohms there, the resistor is what? 34 point what?
5.
34.5 ohms. That's the resistor, right?
Yeah.
Resistance. Now, What do you have now?
60.
Temperature is what? Theta is equal to what now? 60 degrees Celsius, right?
Yeah.
Come again. Use the same formula. We know that theta is what now? What is theta now?
60.
So we now say R60 now. Instead of writing theta, I will write the value for theta. Are we okay?
Yeah.
Good. Equal. Now R0, we don't have any value for R0, so therefore I will bring R0 again. Are we okay? Now come again. 1 is a constant, I will write the 1. Plus, next what we have? Alpha, right? Alpha is the temperature coefficient.
Yeah.
And that temperature coefficient is what we are asked to find, right? So therefore we bring alpha multiplied by the temperature. Theta is what? Theta is what? 60, right?
Yeah.
You now say R60 here is now equal to what do you have here? R0 into 1 here plus 60 alpha now. Call this equation what? Equation 2. Hope it is clear now, right?
Yeah.
Now, since we have gotten equation 1 and equation 2, what do we do now? In this case here, we solve simultaneously actually, yeah. But you know what we can do here? We divide the two equations. Are you okay now, sir?
Yes, sir.
Someone was asking, why I did not multiply to get to this guy here? Because I know that I will further what? Divide the two equations.
So you need to divide.
Yes, sir. Always.
What? Yeah. Show the time.
Always, sir. Okay?
After this step, you divide.
Yes, sir. Are you okay now? Now we have gotten our two equations, right? What do we do now? If you observe that this guy is greater than more than this guy, is that also, sir?
Yeah.
60 and 20, which one is greater?
60.
Make sure the greater value should be at the top.
Okay.
Are we okay? So therefore, divide equation 1 and equation 2, right? Divide 1 and what? And 2. Simple and straightforward, right? For equation 1, for equation 2, what do we have? Equation 2, what do you have? Now you have what? You have I what? R60. Okay? Divided by what? What do you have again? I what? R20, right? We have that is what? With the left hand side. Go to the right hand side again. Apply the same method. For the right hand side, what do you have for equation 2 here? You have R0 here. R0 here into what? 1 here plus 60 what? Alpha. Are we okay here? You know simple, sir?
Yes, sir.
Simple and straightforward.
0.
All over here. R0 here again into what? 1 here plus what? 20 alpha. Are we okay here?
Yes, sir.
Observe something here. This one and this one here will be what? We reduced.
Yeah.
Are we okay here? People are smiling, alright? Simple and straightforward. Now, but mind we have a value for this guy. At 60 here, when the temperature was at 60 degrees Celsius here, what was the resistance here?
34.5.
Now you have 34 here, point what? 0.5, right? All over here, 20. When the temperature was at 20 degrees Celsius, what happens now? 30 ohms, right? We have what? You have 30 ohms equal to next. Look at this guy here, right? Okay. Now this guy and this guy, you don't add them because why? This has a variable. This has nothing like a variable. This is a constant, right?
Yeah.
So what do we do now? Notice this is 1 here, alright, plus what? 60 alpha. All over here, you have 1 again here plus what? Plus 20 alpha. Are you okay here?
Yeah.
Don't cancel this guy here because this guy is not here asked to find. Okay, so the concept here. Observe something here. We have a fraction, right? Two fractions. The sign between them is what? It's an equal sign, right? What do we do now? Cross multiply. So this guy and this guy here. Are you getting the concept now, sir?
Yeah.
Simple and straightforward, right? Good. Now we go. You can start with either of them. 30 here. Now say 30 into what do you have again? 1 here plus what? Plus 60 alpha. Alright? Equal to, now we have what? 34.5 into what? What do you have again? 1 here plus what? Plus 20 alpha, right? Are we okay now?
Yes, sir.
Now let's open the brackets. 30 times 1 here, 30 plus 30 times 60, what is that? 60 times 1 is 0, right? And what do you have now? 120, then also 180.
180.
Are we okay now? 1800, right? 180 here, 0, alpha. Are we cool with this one here?
Yeah.
Good. Equal. Now here again, same as what? As 34 times 1 here, 34.5 times 1, same as what? As 34.5, right?
Yeah.
Now, plus here again, 20 times what do you have here? 690 alpha. Collecting like times, right?
Yes, sir.
Now, this is a constant. Okay? Look at this man here. This man is alpha. We say 1800 alpha. This guy coming over here becomes what? Negative, right?
Yeah.
minus
690
690 alpha again equal over here. What do we have here? A constant 34.5 yeah, minus next one we have here again
Minus 30.
minus 30, right? So this guy, when you subtract the guy, what do you have?
1,110.
1,100 and what?
1,110.
1110, right?
Mm-hmm.
Good. Now we have what? We have alpha equal over here. When you subtract, what do you have?
4.5.
We have 4.5. Now alpha now is equal to divide both sides by what? By 1110. Eh?
Mm-hmm.
Now 4.5 yeah, all by what? 1110. And alpha, the temperature coefficient is equal to what now?
Divide them. 4.5 divided by 110. 0.0000405.
0.00405, eh? Now Kelvin is degree Celsius per Celsius, right?
Or 4.05 times 10 to the minus 3.
That is right. Check it out.
Okay.
There we go, right?
Yes, sir.
This was last year questions. College of Medicine, right?
Yeah.
Physics, 2024 July.
Yeah.
And we have question on question 1D. Here we are asking us to define the temperature coefficient of possible resistance. That's no problem, right?
Yeah.
That is a fraction of what? Fractional change. Alright? In the resistance of the temperature of 0 degrees Celsius. Are we okay here?
Mm-hmm.
Good. Now that KPI is right, so any topic, that's when you can look at the book, it is in there. Now what you're concerned about here is what? Calculate the resistance of tungsten at the temperature of what? Of 20 degrees Celsius if its temperature coefficient of resistance is 0.006 degree per Celsius at what? At 0 degrees, tungsten has a resistance of what? Of 15 ohms. Simple and what?
Straightforward.
And straightforward. Just see this one, don't be afraid. We go. Let's collect the data. Now we have what? We are given here, from this question here, we have what?
The temperature 20
Now,
degrees.
calculate the resistance of what? Of tungsten
Coefficient,
at,
yeah.
at the temperature of what? That is R20, right?
Yes, sir.
Now, we are going to ask to find what? The resistance at what? Temperature of what? 20 degrees Celsius. Are you okay here?
Yeah.
It's not simple and straightforward here.
Yeah.
Yeah, it is so simple and straightforward. Let's go. But if you observe here, we have what? We have R0 here is now equal to what? 15 ohms. Because from the question here, we say what? If its temperature coefficient of our resistance is, also we are given what? Temperature coefficient, right?
Yes, sir.
But the symbol for the temperature coefficient is equal to what?
Alpha.
Alpha. So therefore, temperature coefficient is now equal to what do we have?
0.
Now we have 0.006 degree per Celsius, right?
Yeah.
At 0 degrees, tungsten has a resistance of what? 15, right?
Yeah.
So when the temperature was at 0 degrees Celsius here,
Mm-hmm.
the resistance was what? 15 what? Ohms, right?
Mm-hmm.
Now, what are we asked to find here? We have been asked to find that the resistance at what? At what? At 20 degrees Celsius, right? Are you okay here?
Yeah.
So, resistance at 20 degrees Celsius here is what we are asked to find. So using here, are we getting the concept here? Simple and what? Using here, what do we have here? We have R theta equal to R what? R0 here, are you okay here? R0 here into what? 1 here plus what?
Alpha.
Now we have what? We have alpha what? Alpha theta, right? That is all. Are you okay
Yes, sir.
here?
Before we go forward,
Yes, sir.
how do you distinguish between theta and 0 from the question?
Yes, sir.
How do
Now,
you-
yeah, they made mention of what? Of 20 degrees Celsius, right?
Mhm.
Sorry, 0 degrees Celsius.
Okay.
That's R0. R0 always is what? Is the temperature at what? At 0 degrees
0
Celsius.
degrees Celsius. But
Alright.
what about if they don't give me the question?
Then don't take that one to be R0. Then R0 is not part of the question. So what you must do when you are solving your problem here, you must start to get rid of what of R0. Just like we did for what of the previous question. Look at this question here.
Mhm.
One problem was when the temperature was at 20 degrees Celsius,
Mhm.
what was the resistance here? What was the resistance?
Resistance
Okay.
is yes 3.4.
30,
Yeah,
right?
30, yeah.
What its temperature was what?
20.
20. Are we okay here?
Resistance is 30.
Now,
ohm.
here there was nothing like what? Like 0 degrees Celsius.
Okay.
Now we have what? We have temperature at what? At 6 degrees. We are going to solve more problems.
Alright.
Okay?
Yeah.
Are we okay here?
Yeah.
So that light, what happens now? Here we have R. But theta is equal to what now? What is theta? 20, right?
It's 20.
Theta is equal to what? Let me just put theta
20.
here is equal to what? 20, right?
Yeah.
Now 20 degrees Celsius. And R here is equal to what? Our question. Are we okay here?
Yeah.
Are we okay with this one here? Good.
The problem I'm having is that how do you distinguish between our 0 and that of our theta?
Now we're going to solve more problems for better understanding. Yeah, let's solve one problem to right?
Immediately mentions the temperature at 0 degrees.
0 degrees Celsius. Anyway, it's 0 degrees Celsius. That's R0.
Okay.
Let's look at this problem here. We go.
Yeah.
Now we are giving this problem here from your past paper.
Okay.
Okay, let's go. Are we okay here?
Yes, sir.
Now, R theta. What is that now? What do you have here now? So therefore, it's not what? R20 here equal, what is R0? R0 is brings us to the question, right?
Yes, sir.
R0 is equal to what now?
15.
You write what? 15, right?
Mm-hmm.
Into here, 1 is a constant, put 1. This guy is also given to us in the question. And what is that?
0.0.
Yeah, 0 point what? 006
6.
here multiplied by the temperature there is what?
20.
20. Are we okay here?
Yeah.
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 Good. So therefore, we now have what? R20 here is equal to now 15 is here. Okay? Now 15 here into everything is what?
1.12.
1.12.
Yeah.
And R20 here
16.8.
is equal to what? 16 here point what? 0.8 ohms, right?
Yeah.
Therefore, what is the resistance here?
16.8 ohms.
According to the question here says what? Calculate the resistance of pot of tungsten, right? At what? At the temperature of 20 degrees Celsius. If its temperature coefficient of the resistance is 0.006 degree per Celsius, at 0 degrees Celsius, tungsten has a resistance of what?
Resistance of
15
15
ohms,
ohms.
right?
Yeah.
That's all. So therefore, the resistance needed here for 20 degrees Celsius is equal to what?
16.8.
16.8. That's all. That is all. We are afraid of the question, right? Okay. Yes, sir. What's this guy? Yeah, let's go to problem 2.
Problem 2.
Mm-hmm.
The resistance of a nickel element
Mm-hmm.
of an electric fire
Mm-hmm.
is 50.9 ohms.
Now, of what? Go to the question again.
Okay.
That is nichrome.
Nickel
Chrome.
coal
Cool.
There we go.
elements of an electric fire
Mm-hmm.
is 50.
Wire.
Okay, wire.
Yeah.
50.9 ohms
Mm-hmm.
at 20 degrees Celsius.
Now, you were asking a question.
Yes, sir.
Now, how can you tell that this is for? This is for
R0.
R0.
Mm-hmm. Yes, sir.
You have to get to the question now.
Mm-hmm.
Mm-hmm. Now, we are now given our temperature. What is the temperature given to us here?
It's 20 degrees
Now,
Celsius.
20 degrees Celsius, right?
Mhm.
And that 20 degrees Celsius has what? Has a resistance of what?
50.9 ohms.
50.9 ohms. Are we okay now, sir?
Yeah, yeah.
So look at this one here. If area is equal to what? 50.9 ohms, this man has a temperature of what now? Theta, right?
Yeah, 20
So
degrees.
theta here is now equal to what? 20 degrees Celsius, right?
Yeah.
20 degrees Celsius. Are we okay here?
Mm-hmm.
Yeah, continue the question, sir.
Okay. When operating on a 240 I think V.
Volts.
Okay, volt.
Now we go. Now, voltage here. Alright, on PD, eh? Are we okay here?
Yes, sir.
It just didn't have a question.
Voltage. That is 2 watts. 240, eh?
Yes, sir.
V. Yeah, let's go. We go.
This is not recording now.
We go.
Supply the current flowing through it
Mm-hmm.
is 4.17 ampere.
Now look at this one. We have a question.
4.17.
Okay, 4.
17, not 70, 17, right?
Mhm.
Now,
Okay.
we go again. I, correct, eh?
Mm-hmm.
This thing.
I here is equal to what? 4 point what? 17. That's all.
Ampere.
Ampere, right?
So calculate the steady temperature reached by the electric fire if the temperature coil.
Electric
Am I wrong to call it that way?
Electric
Wire,
4.17.
right? That is why, right?
Yeah, we'll check.
4.17.
Electric wire, if the temperature coefficient
Mm-hmm.
of nichrome
Now, temperature coefficient, right?
yeah,
But we have a formula, we have a symbol.
is
What is that? Alpha, eh?
10
Temperature coefficient is equal to what?
1.7 times 10 to the minus 4
1.7 times 10 to the power
minus 4
negative 4, right?
Kelvin.
Per Kelvin.
Yeah, per Kelvin.
That's the unit. It's can either be what? Per Kelvin or per
Per
Celsius.
Celsius, sorry.
Are you okay now, sir?
Yeah.
But if you observe the question here, what's the question here?
You say if you find the temperature coefficient.
Mm-hmm. No, we are giving the temperature coefficient here.
We have to find our O.
Calculate the temperature reached by the electric wire if the temperature coefficient is so the distance of the is 20 degrees. So we need to find
Read the question. Read the question. Let me know what we have to find.
if we find our O.
Read the question. Let me know what we have to find.
No. We need to find
The resistance of a micron element.
Read the question. Let me know what we have to find.
Read all of it.
Read the question.
The resistance of a micron element of an electric wire
Mm-hmm.
is 50.9 ohms.
Now we have this R is equal to 50.9 ohms, right?
At 20 degrees C.
Yes, sir.
When operating on a 240 volt supply,
Yes, sir.
the current flowing through it is 4.17 ampere.
Mm-hmm.
Calculate the steady temperature reached by the electric wire if the temperature coefficient of micron is 1.7 times 10 to the minus 4 coulomb.
Not Coulomb.
Oh, sorry, Kelvin. Per
Per
Kelvin.
Celsius or per Kelvin, eh?
Kelvin, yeah.
the steady temperature. That's it.
Per theta we have to find.
Yeah.
Look at this one here. We have I theta here is now equal to. Are we okay here?
Yes, sir.
Next, what are we to have? We have here? We have R what? R0 here. 1 here plus what? Alpha
Theta.
theta. Are we cool?
Yeah.
Cool.
Good. R theta here. Let's use this guy first. Over there we have what? We have R to be what? 50.9, right?
Mm-hmm.
And then what? A temperature of 20 degrees Celsius. Is that also sir?
Mm-hmm.
Substitute the values now. Hmm? You have R what? R20 now, eh?
Mm-hmm.
Is now equal to R0 here into here, 1 is a constant here, plus this guy is given to us, right?
Yeah.
And what's that?
It's 1.7 times
Now we
10
have 1.7
times 10 to the minus 4.
minus 4, right?
Yeah.
And here we have what? We have theta. Is that also sir?
Yeah.
Good. Are you okay?
Yeah.
That's it.
So you have to find theta.
But we are not asked to find what? Power, but we are what? We are giving out the values, right?
Yes, of course.
You have what? You have current. Is that also sir?
Yeah, of
Good.
course.
So if you ask to find what theta here in this case now, mind you, Ohm's law.
Yeah.
You know this Ohm's law, right? Hmm?
Yeah.
The voltage here is what? Is directly proportional to what? To the current, right?
Current, yeah.
Is that also sir? Not
Yes.
only the current and what? And the resistance.
Resistance.
That is Vi is equal to what? V is equal to I
IR.
R, eh?
Yeah.
Are you right here now?
Yeah.
When they give you this guy here, it's not by magic. You know, we have another formula for us. Okay, let me leave that. So let me give me so many formulas here for now. But in this guy here, let's make I the subject, right? I here and I here and I here. Alright? This and this we cancel there. And I is now equal to what? What do you have now? V all upon what?
Upon I.
That is the reason why they gave you what? The current and what and voltage.
Mm-hmm.
You see, also is important, right?
To
It's
find the
very much
resistance.
important. Alright? But this R here, you see what? R theta is also sir.
Mm-hmm.
Alright?
Yeah.
This R. Do you know R0 from this question here? R0 is not known.
It's not.
Alright here?
Yeah.
R0 is not known. So therefore, what do we do here? Now we know R, we know R is now equal to what do you have now? What do you have for this guy?
240.
Now you have 240 all over. What do you have for this guy again? 4.17, right? This one gives you, what do you have?
4.17
Yes,
times
sir,
10
what do you have?
to. Just 4.17.
Yes, sir, 4.17.
40 divided by 4.17.
It's 57.55.
Now you have 57 point what?
55.
Now this one is equal to what? 57 here, point what?
55.
0.55. Are you okay here?
Yeah. Ohms.
Ohms. Resistor, right? Now 57.1.55.
Mm-hmm.
Are we getting the concept here, sir?
Yeah.
Are you okay, sir?
Mm-hmm.
Good. So next, we have gotten what? We have gotten what? R, right?
Yeah.
R not is what is not present here. We have R here is what? Is present, right?
Yeah.
What are we asked to find now? The temperature, right?
Yeah,
If
that's
you see
theta.
something here, R theta here is now equal to Now you have what? You have R0 here into 1 year plus what? You have what? You have alpha and you have what? You have theta, right? Good. What is R theta?
Our theta is
What
20.
is R theta here?
It's 20.
It's 20. R theta is 20.
Our theta?
No, Arteta is not given to us.
R theta is not given to us. What is the temperature?
Oh, Arteta,
What is the temperature given to us in the question?
20.
It's 20.
20, right?
Yeah.
Now, R0, what is R0 now?
It's not given to us.
Answer is not known.
R0 is not known, right?
Mm-hmm.
R0 is not known.
It's 0.
Okay, R0 is 57 points.
I get 57.6. Now, come here again. Now, we already have what? R20, right?
Mm-hmm.
Now, what is the value for R20 now?
Our 20
Yes, sir. What's the
is
value?
50.9.
Then substitute that value now. That's what we're going to do now. Alright? So let's use this one first. We have what? We have R theta here, but what is theta now? 20, right?
Yeah.
Equal to R0 here. Okay? And then what do you have here now? 1 plus alpha. What is alpha? 1.7 times what? 10 to the power -4, right?
Mm-hmm.
Times what? Times theta. Times 20, sorry. This is R20, right?
Mm-hmm.
Times 20. Okay? Now we have what? R what? R20 here is now equal to. Now, everything here, what do you have here now? R0 here.
Plus 1.7 times 1.0034.
Everything.
Yeah.
So we have what? 1 point what?
0034.
Times R0. What is that? 1.0034
34 and 0.
R0, right?
Mm-hmm.
But we know what is R20. Is that also, sir?
Mm-hmm.
What is that now?
50.9.
50.9 is now equal to 1.0034 R0.
Mm-hmm.
We can get R0 now, right?
Yeah.
So therefore, now say R0 here is now equal to. Now, what do you have now? We have 50.9 all over 1.0034. And what is R0 now?
50.7.
R0 here is equal to what?
50.7.
50 here, point what? 0.7.
Yes, sir.
Are we okay here?
Yeah.
No, we are going to R0. Now, if you want to use this formula again now, mind you, R theta is not given to us, right? R theta, is it not given to us?
Our theta is 20.
R theta is what is 20, right?
Yeah.
No. Mind you, go to the question again. Now we are going to R0 now. At first, initially here, this question here, we don't say it was R0, right?
Mm-hmm.
But they gave us a value by which we can get R0. Now we are going to R0. But mind you, R0 is not what we are asked to find. But we are asked to find what the steady temperature. Are you okay, sir?
Yes, sir.
That steady temperature is what we are going to look at for now. And if you use this formula here, V is equal to what? IR, Ohm's law. Then we end up having what? This value for R, right? So R is equal to what? This guy.
That's the existence.
That's the existence, right? Have you got the existence now here? Yes. Then where are we going to substitute this formula now? Huh?
To find what?
You only there. From this question here, you have alpha, right?
Mm-hmm.
This theta is what you have asked to find. That's sir. What do you have now?
R0.
R0.
Mm-hmm.
Now you have the value for R0 now, right?
Mm-hmm.
Now what about R now? You know the value for R? Yes, we are going to the value for what for R now, right?
Yes.
Because the steady temperature is what we asked to find.
Yeah.
It's not simple as this one, sir.
Yeah.
Now, area is now equal to what else we have?
50.7.
Now, no, I'm coming here. Let's see the formula now. What do you have now? I what? I zero here into what? 1 year plus what? Plus alpha and here what? You have theta, right? I is what now? 50 point what? Okay, 57 there. 57 here point what? 0.55 here is now equal to, and what is R0 here? 50 point what?
7.
0.7 eh?
Yeah.
0.7, that's what we have. Into here, 1 year plus. Okay, let's take this part. Okay, let's come here. R now is equal to R what? R0, right?
Yeah.
Now into here, 1 year plus alpha theta. And area is now equal to Now only the value for I now. What is I now?
57.
57 here point what? 55 here equal to I zero is what? 50 here point what? 0.7. Okay?
Yeah.
Into 1 as a constant here plus alpha is what? 1.7 times 10 to the power negative 4, right? Times what? Times theta. That's what we have to find.
Yeah.
Are you right now? Now, this guy is here. Now we have 57 here, 0.55. Are we okay here?